Space is more crowded than you might think, and actually galaxies wind up interacting with each other. They actually will merge together. So I'm zooming in now on a pair of galaxies that are merging together, interacting. You can see that they're disturbed.
Imagine gazing up at the night sky, knowing that just over 4 light years away lies a planet that could be another Earth. Proxima b, with its astonishing city lights revealed by the James Webb Telescope, has opened up a world of possibilities. The idea that life might exist beyond our planet is both thrilling and unsettling. Notable figures like Anderson Cooper and Bill Nye have shared their insights on this groundbreaking discovery. When was this revelation made? What are experts saying about its implications? Join us as we look into the terrifying city lights discovered on Proxima b by the James Webb Telescope. The James Webb Telescope has spotted a unique light pattern coming from Proxima b that hints at artificial lighting. This light appears in specific wavelengths, which is different from what scientists see on other planets in our solar system. The most convincing reason for this brightness is the possibility of lights created by an advanced civilization. Other potential causes could be geological activity like volcanoes or changes in the atmosphere, such as reflections from ice or clouds. However, these natural phenomena usually display irregular patterns. What are the implications of this discovery? What impact does this have on Earth? Hold on to your seats because this is big. If confirmed, this discovery would change our understanding of the universe. It would indicate that humans are not alone, and that other intelligent beings might have the ability to create technology that alters their surroundings. Proxima b, the closest known exoplanet to Earth at just 4.2 light years away, may be more Earth-like than previously thought. Research shows that Proxima b's minimum mass is only 17% greater than that of Earth. Scientists studying the planet have detected light, and given its Earth-like characteristics, it suggests the presence of sections and cities on Proxima b. The lights observed could very well come from one of those cities. Scientists explored the possibility of spotting artificial lights from the dark side of Proxima b by analyzing light curves from the planet and its host star. They looked at 2 scenarios, one with artificial lighting similar to common LEDs on Earth, and another with a narrower spectrum that matches the total artificial lighting on Earth. Their findings suggest that the James Webb Space Telescope can detect LED-type artificial lights comprising 5% of stellar power with an 85% confidence level, assuming it operates with photon-limited precision. To detect the current level of artificial lighting on Earth, the spectral band would need to be 1,000 times narrower. These predictions depend on the optimal performance of the NIR spec instrument, and can achieve this, along with future observatories like LUVOIR, which could also detect such artificial lights. Previously, researchers believed this exoplanet, located in its star's habitable zone, had a minimum mass of about 1.3 Earth masses. The new measurements suggest Proxima b might be even more similar to Earth in size than earlier observations indicated. The research team examined Proxima b using the Echelle spectrograph for rocky exoplanet and stable spectroscopic observations, known as ESPRESSO. ESPRESSO is a Swiss spectrograph mounted on the European Southern Observatory's Very Large Telescope in Chile. Spectrographs work by observing objects and splitting their light into wavelengths, allowing scientists to study them in more detail. Proxima b was first discovered 4 years ago using the HARP spectrograph located at the European Southern Observatory's La Silla Observatory in Chile. Recent observations have provided scientists with an updated and precise understanding of the planet. Researchers were already pleased with HARP's performance, which has helped find hundreds of exoplanets over 17 years. The ESPRESSO instrument has now produced even more accurate measurements, reflecting a decade of teamwork among scientists. With ESPRESSO, researchers can measure Proxima b's mass with precision greater than 1/10 of Earth's mass, which is considered remarkable in the field. This unusual exoplanet orbits Proxima Centauri, the closest star to our Sun. Since it orbits within the habitable zone of its star, there is a chance that liquid water and possibly life could exist on Proxima b. Its Earth-like mass leads scientists to believe it could also be a rocky terrestrial planet similar to Earth. However, Proxima b orbits a star that, while nearby, is dimmer and less massive than the Sun. It is thought to be tidally locked, meaning one side always faces the star while the other side remains in darkness. There is uncertainty regarding whether Proxima b has an atmosphere atmosphere. Because the planet is so close to its star, completing an orbit every 11 Earth days, some researchers suggest that radiation from Proxima Centauri might have stripped away its atmosphere, making it challenging for the surface to retain liquid water. As technology advances, scientists will continue to learn more about the true conditions on Proxima b. Proxima Centauri has faced severe space weather from its parent star, and new research has confirmed this troubling situation. Proxima Centauri hosts a small rocky planet located in its habitable zone, a region where conditions might allow for liquid water. This zone is crucial because if a planet is too close to its star, intense radiation can boil away any water. On the other hand, if it is too far, it won't receive enough warmth, causing water to freeze. Astronomers pay close attention to habitable zones around stars, since this is where life as we understand it could potentially develop. Proxima b, the nearest known exoplanet, is of particular interest to researchers. However, any potential life on Proxima b would face significant challenges. Proxima Centauri is a red dwarf star, much smaller than the Sun. Due to their smaller size, the nuclear fusion cores of red dwarf stars are nearer to their surfaces, resulting in more chaotic behavior compared to larger stars like the Sun. This turbulence also enhances the strength of their magnetic fields. These powerful magnetic fields can send intense blasts of high-energy radiation and particles into space. When stars are far away, this radiation is not a major concern. However, since red dwarf stars like Proxima Centauri are not very bright, their habitable zones are much closer to them. This raises questions about how truly habitable these areas are. Although scientists had previously understood that life on Proxima b would be challenging, they lacked precise information about the magnetic field around Proxima Centauri and relied on observations of similar stars for their insights. A recent study created detailed maps of the magnetic field of Proxima Centauri, leading to a model of the solar wind coming from that star. The findings confirmed that conditions on Proxima b are just as challenging as previously thought. This planet experiences around 1,000 times more solar wind radiation than Earth does. This extreme level of radiation makes it nearly impossible for Proxima b to maintain an atmosphere or even have liquid water. While this doesn't entirely eliminate the chance of life existing there, it suggests that any life forms would face much harsher conditions than those on Earth. Understanding the planet's composition and physical features might help scientists determine if life is indeed possible there. Proxima Centauri b likely does not have any tilt, making its axial obliquity minimal. The exact age of the planet is unclear, and Proxima Centauri may have been captured by the Alpha Centauri system, which is about 5 billion years old, suggesting Proxima b may not share that same age. The planet is also not expected to have stable moons orbiting it. As of 2020, the estimated minimum mass of Proxima Centauri b is about 1.173 times that of Earth, with similar estimates appearing over the years. The latest estimate from 2022 suggests at least 1.07 times the mass of Earth, but these figures are all minimums since the exact tilt of the planet's orbit is still unknown. Proxima Centauri b's radius is estimated to be between 0.94 and 1.4 times Earth's, but its exact size is uncertain. If its mass is lower than expected, it could be classified as Earth-like or Neptune-like, depending on its composition. Proxima b might resemble Mercury or contain a lot of water. By studying the ratios of iron, silicon, and magnesium in the Proxima Centauri system, scientists can learn about its makeup. As of 2021, knowledge about Proxima Centauri b mainly involves its distance from its star and its orbital period. Simulations have explored its physical features, assuming Earth-like traits and considering heat generation, rotation, radiation effects, and changes in volatile substances over time. Proxima Centauri b likely formed under conditions different from those on Earth. It probably had less water, faced more frequent impacts, and developed more quickly than Earth did. Assuming it started at its current distance from the star, it is thought that Proxima Centauri b did not form where it is now because there wouldn't have been enough material in the disk of gas and dust around the star. Instead, the planet or fragments of it likely formed farther away before moving to its current orbit. Depending on what materials were present during its formation, Proxima Centauri b might contain a lot of volatile substances. There are various theories about how the planet formed, and many of these depend on whether other planets exist around Proxima Centauri, which could lead to different compositions for Proxima Centauri b. Several ways can bring water to a developing planet, but how much water Proxima Centauri b received is still a mystery. Models by scientists in 2016 suggested that Proxima Centauri b might have lost no more than an equivalent equivalent of one ocean from Earth. However, newer studies indicated that the actual amount of water lost could be much higher. Research from 2017 concluded that the atmosphere of Proxima Centauri b could vanish within 10 million years. These estimates vary greatly because they depend heavily on the planet's initial atmospheric mass, making them uncertain. In the field of exoplanet studies, habitability usually means the chance that liquid water is present on a planet's surface. For life as it is known to exist, liquid water and an atmosphere are crucial. Life hidden below the surface, like those found in the oceans of Europa, would be hard to identify from a distance, even though it might represent a possible life form on Proxima Centauri b. The habitability of planets around red dwarf stars like Proxima Centauri is debated among scientists. Factors such as the star's activity and the tidal locking of the planet could make it challenging for suitable conditions to develop. Unlike other types of radiation, the ultraviolet radiation around Proxima Centauri b is redder and may have less effect on organic materials. High stellar activity on Proxima Centauri b could harm its ozone layer, raising harmful ultraviolet radiation levels. Its elliptical orbit may also lead to time spent outside the habitable zone. While oxygen and carbon monoxide could become toxic in its atmosphere, higher oxygen levels might support complex life. If oceans are present, tides could flood and dry coastal areas, promoting life and biological rhythms like a day-night cycle, which may not develop on a tidally locked planet. Tides would mix nutrients, potentially causing bursts of marine life similar to Earth's red tides. Additionally, red dwarfs like Proxima Centauri have longer lifespans than the Sun, providing ample time for life to evolve. The star's radiation isn't suitable for oxygen-producing photosynthesis, but could support anoxygenic photosynthesis, although detecting such life is difficult. One study estimated that photosynthetic productivity on Proxima Centauri b could be about 20% of that on Earth. Proxima Centauri had attracted interest for exoplanet searches even before the discovery of Proxima Centauri b. Early studies from 2008 and 2009 had ruled out larger-than-Earth exoplanets in its habitable zone. Around dwarf stars like Proxima Centauri, planets are common, with an average of 1 or 2 planets per star, and about 20 to 40% of red dwarfs host a planet in the habitable zone. Red dwarfs themselves are the most frequently occurring type of star. Prior to 2016, instruments at the European Southern Observatory in Chile had picked up unusual signals from Proxima Centauri. What could be causing these mysterious signals? This is the moment we've all been waiting for. These signals were unexplained by flares or chromospheric activity, hinting that a planet might be orbiting the star. In January 2016, a group of astronomers started the Pale Red Dot Project, aimed at confirming this hypothetical planet's existence. By the 24th of August 2016, the team, led by Anglada Escud, proposed that an Earth-like exoplanet in Proxima Centauri's habitable zone could be the cause of these signals, and thus Proxima Centauri b's discovery was announced. In 2022, another planet named Proxima Centauri d, even closer to the star, was confirmed. A planet candidate called Proxima Centauri c was reported in 2020, though its existence has been disputed due to possible data artifacts. Additionally, reports of a dust belt around Proxima Centauri have not yet been verified. A major concern for Proxima Centauri b's habitability is the stability of its atmosphere, impacted by strong UV radiation and X-rays from Proxima Centauri. This planet receives 10 to 60 times more radiation than Earth, with past exposure possibly 7 to 16 times greater. Such high levels of radiation can evaporate an atmosphere over time. Hydrogen absorbs this energy, heats up, and escapes, while radiation can break water into hydrogen and oxygen, allowing heated hydrogen to drag away other elements. Although nitrogen and carbon dioxide can escape too, their loss is unlikely to greatly affect an Earth-like atmosphere. Stellar winds and coronal mass ejections are even bigger threats, with winds on Proxima Centauri b being 4 to 80 times stronger than those on Earth and about 10,000 times more forceful than the Sun's winds. Intense UV and X-rays could lift the atmosphere beyond its magnetic field, worsening losses from stellar winds and mass ejections. At Proxima Centauri b's distance from its star, the stellar wind surrounding it could be 10 to 1,000 times denser than around Earth, depending on the strength and stage of Proxima Centauri's magnetic field. This star has a magnetic cycle lasting 7 years. As of 2018, it remains uncertain if Proxima Centauri b has its own magnetic field, though it's possible the upper atmosphere has a magnetic layer. The planet's magnetic intensity could determine how deeply the stellar wind penetrates, with potential to strip parts of the atmosphere, and this effect may vary day by day and year by year. If Proxima Centauri b is tidally locked to its star, its atmosphere might collapse on the dark side. This risk risk is more prominent if the atmosphere is carbon dioxide rich, though carbon dioxide glaciers might recycle over time. Unlike stars like the Sun, Proxima Centauri's habitable zone was initially farther away when it was in its early phase. Proxima Centauri b may have spent around 180 million years in a position too close to its star for water to condense. As a result, the planet could have experienced a runaway greenhouse effect, where any water would have evaporated into steam, then split into hydrogen and oxygen through UV radiation, and ultimately lost the hydrogen, much like what scientists believe occurred on Venus. Hypothetical impact events on Proxima Centauri b might disrupt its atmosphere further, potentially causing oceans to boil off. A Proxima Centauri b covered in ice with a possible subsurface ocean could experience cryovolcanic activity similar to that on Jupiter's moon Io. This type of volcanism would create a thin exosphere, much like Jupiter's other moon Europa. Even if Proxima Centauri b has lost its original atmosphere, volcanic activity could slowly regenerate a second one, likely rich in carbon dioxide, providing more stability than an Earth-like atmosphere. If an ocean exists, it could also prevent the atmosphere from collapsing, depending on its size and the atmosphere's composition and mass. Additionally, incoming exocomets might replenish the water supply on Proxima Centauri b if they are in the vicinity. It's intriguing to consider what both scientists and the general public might think of these discoveries. First up is Anderson Cooper. Anderson may not be a scientist, but he certainly knows how to captivate an audience with big questions. As an American journalist, television host, and author, best known for his work as a CNN news anchor on Anderson Cooper 360, Anderson frequently covers natural and metaphysical events, so his interest in Proxima Centauri b is unsurprising. For him, this planet serves as a reminder of how tiny humans are in the vast expanse of the universe. He emphasizes how discoveries like Proxima Centauri b spark curiosity, not only among scientists, but also in everyday people. After all, who wouldn't want to know if there's another Earth out there? Anderson points out that the James Webb Space Telescope, the most advanced telescope to date, has detected signs that could possibly resemble city lights. While there's no certainty of alien life, these mysterious lights have ignited discussions. Anderson's view is that such findings unite people by reminding everyone of their small place in a much larger picture. Now, if Anderson's role is to broaden people's curiosity, Bill Nye's role is to dive into the scientific depth of Proxima Centauri b and the possible city lights. Bill explains that Proxima Centauri b lies in the habitable zone, a region around a star where temperatures are just right for liquid water to exist, and where there's water, there could be life. Yet Bill urges caution, noting that while the detected lights might resemble city lights, they could very well be natural atmospheric occurrences. Before imagining extraterrestrial cities with glowing structures, he reminds everyone of the need for more data. These lights could simply be an optical illusion or a unique atmospheric effect not yet fully understood. However, the exciting part is that Bill mentions the James Webb Telescope's ability to scan for atmospheric gases like oxygen or methane that might hint at life. If it detects any of these gases, humanity would be one step closer to answering the ultimate question: are we alone in the universe? Both Anderson and Bill share a common belief: Proxima Centauri b and planets like it inspire continued exploration, deeper learning, and a hope that one day we might discover we're not alone after all. When Barnes Rory from the University of Washington looks at Proxima Centauri b, he raises the question, is it a rocky world? His answers will surprise you. According to Barnes, the chances are promising. Proxima b was detected using the radial velocity method, which only provides a minimum estimate for the planet's mass. Based on data from possible orbital paths, about 95% suggest Proxima b's mass falls below 5 times that of Earth, an encouraging sign for a rocky composition. While tidal lock and stellar flares have already been discussed, Barnes introduces another factor: the planet's evolutionary journey. Proxima's brightness changed gradually over time, according to stellar evolution models, dimming slowly over its first billion years. This slow reduction in brightness implies that for approximately the first 250 million years, Proxima b's surface was likely too hot for Earth-like conditions. As researcher Rodrigo Luger found, placing a planet like modern Earth in that early environment would likely have turned it into a Venus-like world, trapped in a runaway greenhouse state that could strip away all original water. Barnes explains that this water loss happens at the molecular level. Intense radiation from Proxima Centauri can break the bonds between hydrogen and oxygen in water molecules in the upper atmosphere. Hydrogen, being very light, can escape the planet's gravity, which means water cannot reform, leaving the planet dry and uninhabitable. Avoiding or overcoming this early greenhouse effect poses a major challenge for Proxima B's potential to support life. Over time, Proxima Centauri's habitable zone moved closer to the star, suggesting that Proxima B may have lost much of its water in its first 10 million years. And even if some water remained, Barnes notes that the planet's atmosphere might now hold large amounts of oxygen. This reactive element could have interfered with the formation of the basic molecules needed for life. Earth developed oxygen through photosynthesis, but life began here without any oxygen. This creates an interesting situation with Proxima B, where there could be oceans and a lot of oxygen, but not enough conditions for life to start. Future space missions and ground observations will help explore these possibilities. Meadows' research at the Virtual Planetary Laboratory aims to understand Proxima B's atmosphere using spectral analysis. This may reveal oxygen levels that could indicate if the planet has too much oxygen for life to develop or just the right amount for living systems. Barnes argues that tidal locking on Proxima B is unlikely to cause atmospheric collapse, as wind circulation can prevent freezing on the night side. He highlights tidal heating, where a planet's shape changes due to varying gravitational forces, generating heat through friction, especially with an elliptical orbit, while extreme tidal heating could lead to a runaway greenhouse effect like on Venus. He believes Proxima B isn't in that state. He also considers volcanic activity and large ocean waves. The strength of the magnetic field will influence the atmosphere's ability to support life. Barnes calls for more research on habitability in 2 new papers from the Pale Red Dot study. Evidence of a second planet around Proxima Centauri may affect Proxima B's orbit. As research advances, scientists hope to determine if Proxima Centauri can support life, with more observations planned. If Breakthrough Starshot succeeds, Proxima B may be explored up close later this century. What are your thoughts on the possibility of another Earth existing elsewhere in the universe? Are we actively pursuing discoveries that could transform our way of life? Drop your thoughts in the comments. If you enjoyed this video, remember to like, share, and subscribe to our channel. Don't forget to check out the next video on your screen. You will enjoy it.